Now in this tutorial, we're going to be continuing on solving with the previous exercise that we have started with in the previous tutorial. We have already managed to solve parts A and B. Now we're going to continue with C and D. Starting off, let's reread the question. It says, by drawing suitable tangents on tracing paper, find the gradient of the graph at C, where x is equal to half. So let's go ahead at x equal to half and see where the curve intersects. Now, as you can see, it intersects right here. So what's going to happen is that we're going to have to pivot the ruler in a position where it intersects with the curve at only one point and forms two equivalent angles on both respective sides. Now, after we do so, let's go ahead and find the placement of the right triangle, which is made up of the rise and the run. That concludes our gradient. Starting off, I'm going to place the right triangle somewhere in this position where it shows us how it is pivoted downwards in terms of rise, since the gradient was moving downwards, of course. So this is the run and this is the rise. Now, after we have found this, let's go ahead and count them. We have 2 units for the run. As for the rise, we have somewhere around -5 to 5.5 units, almost 6. So since this measurement is not 100% accurate, we're going to have to say that this is slightly above 5. So I'm going to say -6 for the rise. Now it's negative, of course, since the motion was downwards. Now, for the rise and the run, we say -6 divided by 2, and that would be -3, which is the gradient at x equal to half. So that would be the value of the gradient. Now, moving on forward to part D. Part D says x equal to 1.5. So let's go right here between 1 and 2 and see where it intersects right here. So again, bring on the ruler and draw a tangent. So the tangent, of course, right here intersects only at this point, x equal 1.5, and forms these two equivalent angles. Now that we have drawn the tangent, let's go ahead and find the rise and the run in order to calculate our gradient. After drawing this right triangle right here, we can actually calculate it. So we have a run of 2 points, so that would be the run. As for the rise, it is somewhere above the 1 point mark, but less than 2. And it is somewhere around 1.2. So I'm going to say rise equal to plus 1.2. So for the gradient at x equal 1.5, rise divided by run is 1.2 divided by 2, and that would be 0.6. The gradient at x equal to 1.5.